Hello there guys, and welcome back to another epic inexorable video. In this video we're taking a look at the second part of solving quadratic inequalities, okay? Now we've got a question on the board, looks a little bit confusing, not gonna lie. Maybe I'm confused a little bit too, hopefully not. We want to solve 2 over x is less than 1 with the extra bit of information that you should not be scared by. X is not equal to 0, okay? So this is the not equal to sign. It's an equal sign with a line through it because it's like, nuh-uh. It's like when you cross something out, it's like, no thank you guys, we don't want x being equal to 0. So hold on, first of all, why isn't x allowed to be equal to 0? What's that all about? Who made that up? Well, the only reason why is because we have 2 divided by x is less than 1. You cannot divide by 0. It's just illegal in maths. You just can't do it, okay? Don't ask why, you just can't. Yeah? So we're just gonna leave it like that. If you can't divide by 0, guys, which you can't, then x cannot be 0 because this is 2 divided by x, okay? And that's it, that's it. If you see something like this, like x does not equal 0, x does not equal 1 or something like that, it's normally because if you were to put that number into the equation, it would give you a denominator of something that is not, like something that would end up being 0, and then the whole thing would be undefined, okay? Or if you know anything about trigonometry, you might have like tan x, y equals tan x, x cannot be 90, for example. The reason, again, would be that it's not defined, because tan of 90 is like infinity, okay? Not really, it's not defined, doesn't have a value, okay? So anyways, we'll talk about that later. The only reason we do this is simply because it would break the equation if we did. So another thing is like, hold on, this isn't a quadratic. That's just not a quadratic, so what are you talking about? That is definitely not in the form y is equal to or greater than or less than ax squared plus bx plus c. It's just not. So what are you doing? This is where we need some serious mental waves, okay? This is really important. If you have an inequality, first of all, what would you do, right? I would multiply both sides by x because then you don't have a fraction. And when you're solving something, basically what you're doing is trying to just get rid of the fractions. That's mostly the first thing you want to do. But here's the thing, guys. What if x was a negative number? Think about that. If x was a negative number and we multiplied by x, that would actually flip the inequality. But we're not going to flip the inequality because x might be a positive number. So whatever we do, we're going to be wrong because we are missing out solutions. If x is negative, the inequality is going to go one way. If it's positive, it's going to go the other way. So what do? We do something really clever. If you ever have to multiply by an unknown number in an inequality, I can just about got that out, in an inequality, you must multiply by the square of what you're supposed to be multiplying by, which means you need to multiply both sides, not by x, but by x squared, okay? Why do we do that? Because x squared is always a positive number, even if x is negative. And it's already told us, guys, x isn't 0. So don't come at me with like, well, it's not positive if it's 0. It's not 0 because it says it in the question. So guys, let's times both sides by x squared. Okay, 1 times x squared is x squared. 2 over x times x squared. Well, one of these x's is going to cancel out, and we end up with 2x is less than x squared, okay? You must do this every time. If you have an unknown number or value or variable in the denominator of a fraction, you have to multiply by the square of it, okay? Now, that's more like it. That is an inequality. And that is something that at least a bit more resembles a quadratic. Now guys, we're going to use the same method as in the previous video in part 1. we're going to get everything onto one side. So I'm going to subtract x squared from both sides. So I'm going to get 2x minus x squared is less than 0, okay? I hope that step makes sense. All we're doing is we're taking, I'm going to sort of unbox this just in case you guys think that, like, I don't know why I did a box around it, to be honest, but, you know, there was a box, there's no box anymore. Okay, so we're taking the x away from both, x squared away from both sides, we end up with this. Now, guys, we're going to have to draw this in a second, and I don't really want to try and solve this nonsense. Actually, in all honesty, I take that back, guys. I don't think we need to multiply both sides by -1 to make our x squared positive. I think we can just factorize this, okay? So, guys, let's factorize. We're going to factorize, both of these are multiples of what? X, because it's 2 times x and minus x times x. So we're going to take an x out, times it by 2. This is just factorizing this thing, guys. And we're going to take away another x, and that's less than 0. That is just factorization. We should be happy with it. If you don't believe me that this is the factorized version of this, expand this out, you will get back there. And also, that should just be like x times 2 is 2x, x times negative x is negative x squared. It's still less than 0 because that was less than 0. We haven't changed the value of it, we've just rewritten it. Okay. So now we say, and by the way, guys, this is actually something crazy. This is where we actually want to add in this equality symbol. As you can see here, we want the equation, okay? So now, guys, we're going to consider, again, I'm going to put a line under here. We're going to consider x times 2 minus x is equal to 0. Or in other words, this one up here, 2x squared 2x, not 2x squared, minus x squared equals 0, okay? These are the same thing. We're going to draw the graph. Use a ruler in the real exam, guys. I have got a further maths exam in about 8 days, so I should probably revise drawing straight lines. That was very funny. So, guys, where's the y-intercept on this bad boy? Where's the constant? There isn't one. There is no constant, which means it must be 0. Which means, luckily for us, which is nice and easy, we've already found one of the roots. That is a point, 0, 0, okay? Like, I'll mark it in a second. That's one of the points. Another point, guys, just looking at this bad boy here, x is 0. We got that from this. This is x times 2 minus x, which means either x is 0 or 2 is 0. Oh, sorry, x is 2, not 2 is 0, guys. That would be very bad. I can't believe that. So there we go, there's our answers here. So if x is 0, that's that one, and if x is 2, that's that one. And guys, actually this time, x squared is negative, which means it's going to be a sad face. So we're going to come up, and we're going to come down, and that's the graph this time. And this is the graph 2x minus x squared, or I should say y equals really. This is the graph of y equals 2x minus x squared, okay? If you're a bit uncomfortable by like the way that we did that, we didn't really like rearrange stuff, we sort of factorized it when x squared was negative. If you're not happy with that, you can do it your own method. You will get the same thing, okay? You can draw another graph where this thing will actually be positive, but we're just going to be looking at a different sort of region in the graph. So what I mean by that is, hypothetically, if you multiply this bad boy by -1, this would flip. Your graph would look like, if you can sort of, I won't actually draw it, but if you can imagine a happy face. But remember, we are looking for when this thing is less than 0. So when is it less than 0? Well, it's less than 0 across all here, and it's less than 0 across here. I'm not sure what notation I'm using at the moment. I'm just using, I don't know, stitches, right? Looks like some Nightmare Before Christmas stuff going on. But like that, those points on the line, okay? Now, if this thing was a happy face, we would actually be looking for when it's greater than 0, which, if you imagine, I will do the dots. Let's say our happy face looks like this. It's the negative version of the graph that we've got. The points would be when it's greater than 0, which would be up here. But all of these points actually correspond to all of these points, so actually you'd get the same answer, okay? I don't know how well I explained that last bit, don't worry about it too much. I'm just saying, if you do this a different way and you get a totally different graph, like that's fine. You can still get the same answer even if you do a totally different graph to me. If that's confusing, then like it doesn't matter. It's not a big deal for this topic. Just solve this stuff however you want to solve it. So x is 0, x is 2. We want when it's less than 0, which is this part of the graph. It's all of this region, all of this, and all of this. This is the point 0, 0. This is the point 2, 0. So guys, what's the region where x is less, or sorry, when y is less than 0? Well, it's when either x is smaller than 0 or when x is greater than 2. Because when x is smaller than 0, we are over here. This is the region. When x is greater than 0, when x is greater than 2, we are over here. So in both cases, that is the valid region. So you would put as your answer this. You could do it in one go as well. You could say like 0, x, 2, x needs to be bigger than 2, x needs to be bigger than 0. You could do it this way around as well. X must be greater than 2, x is less than 0. That's also correct. But it's one of these sort of versions, okay? These are the answers. Either one is fine, okay? And that is it. So guys, if you enjoyed this video, please like, subscribe, share, do whatever you want to do. If you'd like me to make more of these videos on sort of solving quadratic inequalities, I do see how this could be a bit of a weird topic for a lot of people. Like this doesn't look like a quadratic. I know we've said it already, but it's true. If you'd like me to do more of these videos, please let me know and I will. Just ask, okay? As always, just with any topic, just ask what you want me to do. Anyways, thank you so much for watching and I'll see you in the next video. Cheers.